It is unfortunate that only 9% of National Electrical Code, or NEC, users actively participate in the code development process. This limited involvement signifies that the overwhelming majority, specifically 91% of individuals who rely on the code for their work, do not directly influence its alterations and updates. This situation raises concerns because it could result in a code that doesn't fully address the requirements and perspectives of its primary users. There are several contributing factors that might explain this low participation rate. Firstly, many users may simply be unaware of the opportunities available to contribute to the code development process. Secondly, some individuals might lack the necessary time or specialized knowledge required to effectively participate. Thirdly, a segment of users may feel discouraged, believing that their contributions would not be adequately valued or taken into consideration. To improve this situation and foster a more representative code development process, it is crucial to encourage greater participation from NEC users. This would ensure that the code reflects the diverse needs of the majority and remains current with the latest technological advancements and industry practices. To achieve this goal, several steps can be taken. Firstly, it is essential to raise awareness among code users about the avenues available for participation. This can be accomplished through various channels, such as industry publications, online forums, and educational programs. Secondly, providing training and resources can equip individuals with the skills and knowledge necessary to actively contribute to the code development process. This could involve offering workshops, webinars, and online tutorials that cover relevant topics such as code interpretation, proposal writing, and committee procedures. Thirdly, creating a welcoming and inclusive environment is crucial to encourage participation from a diverse range of users. This means fostering a culture of respect, collaboration, and open communication, where all voices are valued and heard. Finally, it is essential to demonstrate that all input is valued and carefully considered. This can be achieved by actively soliciting feedback from users, responding to their concerns, and incorporating their suggestions into the code whenever possible. By implementing these measures, the National Electrical Code can remain a valuable and relevant resource for all users, ensuring that it reflects the evolving needs of the electrical industry and promotes safety and innovation. The NEC is a comprehensive document that outlines the standards for safe electrical installations. It's revised every 3 years through a process that involves public input and technical review. This process is designed to ensure the code remains up to date and reflects the latest advancements in electrical technology. Understanding the NEC development process is crucial for anyone working in the electrical industry. It allows you to stay informed about changes to the code and provides an opportunity to contribute to its improvement. The process begins with a call for proposals from the public. Anyone can submit a proposal to change or add to the NEC. These proposals are then reviewed by technical committees, which are composed of experts in various areas of electrical safety. The technical committees evaluate the proposals based on technical merit, cost-effectiveness, and safety considerations. They then make recommendations to the National Electrical Code Correlating Committee, which has the final say on whether to adopt the proposals. The NEC is organized into chapters, articles, and sections, each covering a specific aspect of electrical installations. Chapter 1 contains general requirements, such as definitions and rules for electrical calculations. Chapters 2 through 7 cover specific types of installations, such as wiring methods, equipment, and special occupancies. Chapter 8 covers communications systems, and Chapter 9 contains tables and examples. Within each chapter, articles provide more detailed requirements for specific topics. For example, Article 210 covers branch circuits, which are the circuits that supply power to outlets and lighting fixtures. Within each article, sections provide even more specific requirements. For example, Section 210.52 specifies the requirements for the identification of grounded conductors. Understanding the NEC involves more than just memorizing the rules. It requires the ability to interpret the code and apply it to real-world situations. This requires a strong understanding of electrical theory, as well as practical experience in electrical installations. There are many resources available to help you understand the NEC. These include textbooks, training courses, and online forums. It's also helpful to attend industry events where you can learn from other professionals and ask questions about the code. The NEC is a living document that is constantly evolving. It's important to stay up to date with the latest changes to the code to ensure that your electrical installations are safe and compliant. The National Fire Protection Association, or NFPA, offers several resources to help you stay informed about changes to the NEC. These include the NEC Handbook, which provides explanations and examples of the code requirements, and the NEC Update, which is a newsletter that summarizes the latest changes to the code. In addition to understanding the specific requirements of the NEC, it's also important to understand the underlying principles of electrical safety. These principles include preventing electrical shock, preventing fires, and protecting equipment from damage. Electrical shock can occur when a person comes into contact with an energized conductor. To prevent electrical shock, it's important to use proper grounding techniques, to use ground fault circuit interrupters, or GFCIs, in wet locations, and to wear appropriate personal protective equipment, or PPE, when working on electrical equipment. Electrical fires can occur when electrical circuits are overloaded or when there are loose connections. To prevent electrical fires, it's important to use the correct size conductors for the load, to make sure that all connections are tight, and to use arc fault circuit interrupters, or RFCIs, in bedrooms and other areas where people sleep. Electrical equipment can be damaged by overvoltage, undervoltage, and surges. To protect equipment from damage, it's important to use surge protective devices, or SPDs, and to ensure that the voltage is within the acceptable range. The National Electrical Code addresses many aspects of electrical installations, including wiring methods. Wiring methods refer to how electrical conductors are installed and protected. The NEC specifies different wiring methods for different applications depending on factors such as the environment, the voltage, and the type of occupancy. Some common wiring methods include non-metallic sheathed cable, or NM cable, also known as RMX, which is commonly used in residential wiring, rigid metal conduit, or RMC, which is used in commercial and industrial applications where physical protection is needed, electrical metallic tubing, or IMT, which is a lightweight conduit that is easy to install, liquid-tight flexible metal conduit, or LFMC, which is used in wet locations, and cable tray, which is used to support large numbers of cables. The NEC also addresses grounding and bonding. Grounding is the process of connecting electrical equipment to the earth. Bonding is the process of connecting different metal parts of an electrical system together. Grounding and bonding are essential for electrical safety because they provide a path for fault current to flow back to the source, which trips the circuit breaker or fuse and energizes the circuit. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. It also specifies the requirements for grounding different types of equipment, such as receptacles, lighting fixtures, and appliances. The NEC also covers overcurrent protection. Overcurrent protection is the use of circuit breakers and fuses to protect electrical circuits from overloads and short circuits. An overload occurs when too much current flows through a circuit, which can cause the conductors to overheat and potentially start a fire. A short circuit occurs when there is a low resistance path between two conductors, which can cause a large amount of current to flow and damage equipment. The NEC specifies the requirements for the size and type of overcurrent protection devices. It also specifies the requirements for the location of overcurrent protection devices and for the coordination of overcurrent protection devices. The National Electrical Code also addresses wiring devices. Wiring devices are components such as receptacles, switches, and lighting fixtures that are used to connect electrical equipment to the wiring system. The NEC specifies the requirements for the type, rating, and installation of wiring devices. It also specifies the requirements for the wiring connections to wiring devices. For example, the NEC requires that all receptacles be grounded and that all wiring connections be made with approved methods. The NEC also covers electrical equipment. Electrical equipment includes items such as transformers, motors, and generators. The NEC specifies the requirements for the design, installation, and maintenance of electrical equipment. It also specifies the requirements for the protection of electrical equipment from overcurrent, overvoltage, and undervoltage. For example, the NEC requires that all transformers be protected by overcurrent devices and that all motors be protected by overload relays. Special occupancies are locations that have unique electrical requirements due to the nature of the occupancy. The NEC contains specific requirements for special occupancies such as hazardous locations, healthcare facilities, and places of assembly. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC specifies the types of electrical equipment that can be used in hazardous locations and the wiring methods that must be used. Healthcare facilities are areas where electrical equipment is used to support patient care. The NEC specifies the requirements for the reliability and grounding of electrical systems in healthcare facilities. Places of assembly are areas where large numbers of people gather. The NEC specifies the requirements for emergency lighting, fire alarm systems, and other safety systems in places of assembly. Chapter 9 in the NEC covers tables and examples. Chapter 9 contains a variety of tables that are used to determine the ampacity of conductors, the size of conduit, and the number of conductors that can be installed in a conduit. It also contains examples of how to apply the NEC requirements to specific situations. These tables and examples are essential tools for anyone working in the electrical industry. They can help you to ensure that your electrical installations are safe and compliant with the NEC. Staying updated with the National Electrical Code is crucial. There are several ways to stay current with the NEC. You can subscribe to the NFPA's newsletter, which provides updates and changes to the NEC. You can also attend industry events and training courses to learn about the latest code requirements. Additionally, you can consult with a qualified electrical inspector or engineer to ensure that your electrical installations are compliant with the NEC. Code compliance is a fundamental aspect of electrical work. Adhering to the NEC ensures the safety of people and property. Non-compliance can result in fines, penalties, and even legal action. It is essential to understand and follow the NEC requirements to ensure that your electrical installations are safe and compliant. In summary, the National Electrical Code is a comprehensive document that outlines the standards for safe electrical installations. It is important to understand the NEC and to stay up to date with the latest changes to the code. By following the NEC requirements, you can help to ensure that your electrical installations are safe and compliant. The NEC is not just a set of rules, it is a guide to safe electrical practices. It is a living document that is constantly evolving to reflect the latest advancements in electrical technology. By participating in the code development process, you can help to ensure that the NEC remains a valuable and relevant resource for all users. The goal is to encourage wider involvement so that the NEC can effectively represent the electrical industry's evolving landscape. This includes ensuring that the code remains adaptable to technological advancements. The NEC ultimate objective is to safeguard both people and property by establishing rigorous standards for electrical practices. Regular updates and revisions are therefore crucial for maintaining its effectiveness.